Hi everyone! In this video I will show you how to use the QTest Editor module so you can write your own Java programming problems. So let me get started by opening the QTest module. I will go to the folder where I have QTest, and depending on the operating system you're using, so if you have Mac, you will just double click on QTest Mac. If you have Windows, you double click on QTest Windows. I have Linux, so I'm going to use QTest from a terminal. So I'm going to open a terminal. I will type QTest, okay, and I'm getting the QTest launcher over here that is asking me which module of QTest I want to run. I want to run the QTest Editor. A nice thing of the QTest Editor is that it's totally local, so it does not use the internet connection to connect to the server. You don't need to enter any username or passwords. You can just click Editor and you're ready to go. So the QTest Editor is composed of two main panels. You can see on your left there is a text editor, essentially, where we are going to write the definition of our problem. And on the right side, in this gray area, you will see a representation of the problem as the students will see it if they receive that problem into a practice quiz or an actual quiz or exam. Very good. So to facilitate our job, the QTest Editor gives us some templates, and we can access those templates by pressing New. So when I click on New, I can recall a template for any of these types of question. For this tutorial, we're going to write a problem writing question, which is a Java code type of question. So I'm going to select Java code, click OK, and here I have a template, an almost empty template of a new problem, a new question. So let's take a look at how the definition of the question looks like and all the different components. So every question in the QTest format starts with the tag question and ends with the tag /question. So the entire question is defined inside these two tags. Okay? So all the elements that we have are represented here. The first one is title. That will include the title of my problem. So for the sake of this tutorial, I'm going to write a very simple Java programming problem that will ask students to write a program to draw pentagons. Okay, so I'm going to give a title to this question, pentagon. Okay. And you can see that as I type here, on the left side, the right side is also getting updated. So every time I type anything in here, the view on the right side gets updated correspondingly. Okay, so title includes the title. Type is Java code, and that tells QTest that this question is of type programming question. Okay, programming question in Java. Points, in the context of a real exam, would be how many points this question is worth. For this exercise, let's put a number of points that is representative of the relative difficulty of the question that we're writing. This, I would say, if it's an easy question, let's put 1 point. If it's an intermediate question, let's give it 2 points. And if it's a harder question, let's give it 3 points. This is going to be a very easy question, so I'm going to give it 1 point. Okay? So pentagon is worth 1 point. Very good. Now I have the tag text, which represents the beginning of the text of the problem, and the corresponding closing tag, which is /text, which represents the end of the text. So anything that is between these two tags will be rendered as the text of the question. So let me type the text. So write let's give it a little bit of context. Using Java and Turtle graphics, write a method named pentagon turtle t double size that takes a turtle T and that takes a turtle and a double representing the size of the pentagon to be drawn. Okay, notice that this text is not very clear because we have no reference to what is the pentagon to be drawn. So let me explain it a little better. Using Java and Turtle graphics, write a method named pentagon, turtle C double size, that draws a pentagon using a given turtle. The parameter size represents is a double that represents the length of the side of the pentagon. Okay? So this is a little bit more clear. Using Java and Turtle graphics, write a method named pentagon that draws a pentagon using a given turtle. The parameter size is a double that represents the length of the side of the pentagon. Let's also give a little example. So since this is a graphical problem, I may want to include a figure. I will show you how to include the figure a little later, but let me just add in the text that there is a figure. For example, the figure below is the result of a call to pentagon T150. Okay? Very good. So this is the text. Figure will contain the figure. I will show you how to insert the figure as a very last thing. Then we have two more elements that we need to fill in: init and answer. Answer will contain a working solution for this problem. Notice that the students will not see the answer when they take the quiz, but they will see it when they review the quiz. And so it's very important to include a working answer in the problem definition. What is init? Init is the initial code that the students will see when they open the question. So you can use this init block to put boilerplate code that is not particularly interesting, but it's necessary for the program to work, but you don't want the students to spend too much time typing up. So usually in my quizzes for CS 170, I put at least a skeleton for the class, and then the signature for the main method with a little bit of comments guiding the students for where they need to write their code. Right? So this is more or less the structure that you see in many of my quiz questions. If you want to include additional auxiliary methods or helper methods, you can write them here. So you can put them in the init block, and students will have them available when they see the question in the system. Okay, so let's work on writing an answer for this problem. I could type it here, right? I could just start typing public blah blah blah, but there is actually a quicker way, and that is to use the code editor that students will also use to write up my solution, and then I will copy paste my solution in the answer block. So let's do that. So public static void pentagon turtle t double size. Okay. Let's see. I'm going to use the turtle t that is passed as a parameter and the size that is also passed as a parameter. So I just need a for loop for int I equals 0, I less than 5, because it's a pentagon, I plus plus, t forward size, t left 72. Okay, 72 is the size of the exterior angle of the pentagon. Very good, so now we wrote the code, so let's write some test case here in the main method, and I'm going to write the test case that will also generate the figure that I mentioned in the text. So over here I need to create a turtle, so turtle t equals new turtle, and then I can call pentagon t 150. Okay, so if I didn't make any mistake, this code should work. Let me, instead of calling public class X, let me just call it public class pentagon. It doesn't make any difference, but it's nicer to have the name of a class that actually represents what the program does. Okay, and also I don't need this comment anymore. Okay, so this is a nice way to write the solution. So let's figure out if it works. So I can execute the code here, and yes, here it is. I drew my pentagon. Of course, if the code was more complicated, I would need more test cases, but for the sake of simplicity, I'm just going to write this single test case for this example. Now, before we forget, let's close this, and let's copy paste this into the answer block. Notice that as soon as I type anything into the editor on the left-hand side, the right-hand side gets reset. So don't make this mistake. Sometimes I do it, I forget about it, I type stuff, okay? Then I go here and I just type one space and all my work is gone, okay? So just don't do that. Or if you do, well, you will learn quickly that you shouldn't. Okay, so now we have almost everything. We have the title, we have the type, we have the points, we have the text, we have the init, we have the answer. We are still missing the figure. So to get the figure, here is a simple way to do it. So let me execute the code one more time. Okay, and I'm getting this nice figure. And then I can use the functionality of the turtle library to go and save the figure. So I can go File, Save Drawing. In QTest Editor, figures must be in PNG format. Okay, so you will save it in PNG. And I'm also going to crop the image. Cropping the image means that it will get rid of the blank areas around the figure itself. Okay, and I may or may not include the turtles. Here I will leave it because it shows where the turtle starts and where the turtle ends. It's up to you whether to include the turtle or not in your figure. So let me save it. Let me save it in Davide, file name pentagon.png. Save. PNG image saved. Very good. So let's close this. Let me go close. Let me go to my files and let's see if the figure has been saved correctly. There you go, Pentagon PNG. If I double click on it, I can see it. Okay, it's 243 times 239 pixels, which is a good, nice and small compact size. It's 2.2 kilobytes, so it's not too big. It's not going to be too cumbersome. You will see what I mean in a second. Okay, so how do I insert the figure in here? The way QTest wants the figure to be inserted is in a base 64 textual representation of the file. Whoa, 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 what is this? Essentially, it's a particular encoding of the content of the file that can be copy-pasted into a text file. Okay, that's what base64 is. The good thing is that the QTest editor will convert the file for you, so you don't have to worry about doing it separately. So I can just go and do insert figure. I find the file that I saved before, pentagon.png, open, and there you go. You see that this collection of characters, this sequence of characters, represent this figure that has been painted over here on the right hand side. This space is not necessary, you can get rid of it. Okay, so this is a pretty nice, neat, compact representation. If you are if you want to make it even more compact, I can show you a way for you to do that, and that can be very handy if the figure is bigger and you see that it clogs a lot of your text editor space. You can do something to make it smaller. So let me show you how. When you save the figure in the Turtle library, the PNG figure is saved with 24-bit colors, which means 16 million possible colors. But as you can see, this figure only uses two colors, black and white. So what we can do is we can go to an image editing software and convert this figure from 24 bits to just 2 bits. And that will save a lot of space in the file. So let me do that for you so you can see how this is done. Well, this will be very much dependent on the computer you use, the software that you have installed. I'm going to show you how to do it using GIMP, which is an image processing editor for Linux. It also works on Windows and Mac, I think. So I go to open with another application, GNU Image Manipulation Program, which is GIMP. Okay, select. Now GIMP opens my figure over here. I can go to colors, no, image, okay, mode. Here you see that RGB is the current mode of my figure. I want to convert it to indexed. And specifically, I want it to use black and white 1-bit palette, which means 2 colors. And that's the smallest possible format that you can have. Then you go to convert, okay? And now we have the indexed figure. Okay. So now we can just go and save it. I can go to export as, I can go pentagon.png, export. Oh, I want to show you the before and after. So notice that before, so the file was 2.2 kilobytes. Okay. Now, as I replace it and I remove these extra fields, resolution, creation time, EXIF data, thumbnail and color profile. I don't need any of these things. I just want my file to be as small as possible. I go to export. Now I can close this. And now notice that from 2.2 kilobytes, this one is now only 765 bytes, which is 0.7 kilobyte. So we significantly reduced the size of the figure. And we will see it here very visually. So now I'm going to delete this and I'm going to reinsert it with the smaller file. Open. Do you see how much smaller the representation of the figure is? But the figure is identical, right? So because we essentially got rid of the unused colors that were available in the previous file, but they were not used. So in this way, the size of the file is more compact. Now, it's not a huge deal, even before the file was compact enough, but you know, we're computer scientists, we like to optimize things and make them smaller and neater if possible. Very good, so this is complete now. QTest Editor does not offer you a save button, So to save your question, you can just copy paste it into a text editor. Okay, so you can open Atom, and this is a Hello World Java. Let me just do File, New File. I can just copy paste the content. Okay, make sure that all the tags are intact. So we start with question, we end with /question. Okay, and now I can save it. Save as here, home, question dash pentagon dot XML. So XML stands for Extensible Markup Language, and that's the kind of format that uses these particular type of tags. So whenever you see files with these kind of tags, usually they are XML files. Okay? So let me just save it here, save, and you see that Atom recognizes that it's an XML file and color codes the tags. Very good. So now this question is saved on my hard drive. So if I want to go back to it later to make some changes, what I can do is I can reopen my QTest editor. Okay. And I can simply copy paste this file definition, this XML definition into the into the editor, and I can make whatever change I want. Okay, so very good. Thank you for watching this video. I hope you will have fun writing your own problems in QTest, and that will make you a better programmer, will make you better at writing, better at coding, and overall, I hope you will have a good experience. Okay, I will see you in the next video or in class. Have a good day.